Hi, this is James Page for ECOC TV. I'm very pleased to have been joined by Roshene McCool, who's just come from the Market Focus stage. Roshene's from Corning, where she is the Senior Commercial Technology Associate. Roshene, thanks for joining us. Really interesting presentation. You started off by talking about problems with growth and with how much the networks are under strain. But how much strain are they under, and are there any particular parts that are giving concern?
So networks are at round about 45% utilisation, and we're seeing 30 to 40% compound annual growth rate across all applications. So that's submarine, that's long haul, it's in access, it's in the metro. So those bandwidths and the amount of data that's being used is going up everywhere.
And so, but they're 45% utilised at the moment, so that sounds fine. There's plenty of headroom, isn't there?
Well, we're okay today, but if those bandwidths keep going up, so if traffic keeps rising at a 30% compound annual growth rate, within 3 years that network will be used up.
And some of the biggest area of growth was machine-to-machine communications.
Yeah, in fact we see 3 times the number of machine-to-machine components in the network compared to consumer devices. So those are really on the rise, and if that continues to grow like that, then networks are going to be under pressure for some time.
Okay, so what are some of the solutions to that and preventing the overload that we're predicting to see? So we need to make existing fibre perform better, do we?
So our colleagues in the industry have done a really, really good job at increasing bandwidth. So we've been increasing bit rates, we've been increasing the number of wavelengths, the modulation schemes. But we're reaching an asymptote where we're putting 80% of our effort into 20% of the gain. Whereas what we can do to multiply that network capacity is simply increase the number of pathways within the cable. We can do that by having ever fibre in cable density. So there are means of doing that. We can do that with fibre that's ever smaller. And Corning have released a product last year, their SMF28 Contour. That's a 190 micron fibre, and that's a 40% reduction in cross-sectional area compared to standard single mode. And not only that, but we need, as we reduce that size, we need to maintain those splicing ecosystems. So for instance, we need to maintain the cladding of the fibre at a 125, which is the same as existing fibres. We need to maintain the mode field diameter at 9.2, which is the same as existing fibres. And that ecosystem is really important.
Okay, well, maybe let's go into the ecosystem in a bit more detail, because you talked about what we can do with the fibre itself, but it's about more than that, isn't it? It's about everything that joins to the fibre.
Yes, it is. So as we look to the future, we might be looking at more radical fibre designs. So for instance, we might be looking at multi-core fibre, where you put multiple cores of light carrying path within a single fibre. Now that obviously is a big radical change, and we as an industry will have to galvanise around a solution of that type. Maybe we go for even smaller fibres, maybe we go for fibres with a few modes in them, but whatever it is we do to increase those fibre pathways, there has to be a splicing ecosystem, transmitter ecosystem, connectors. There has to be a whole kind of body of effort in the industry to make sure that the next generation of fibres are as useful as the current generation.
Fantastic. Well, really interesting, and sort of looking forward to that development over coming years to see that ecosystem growth. But for now, thank you for coming and explaining that to us.
Thank you very much. Thank you.